So climate change is a super hard problem because it's got two components that in combination, I think, make it unique in the history of human challenges. And what those are, first of all, climate change is a collective action problem. The problem with climate change is not inherently that warm climate is bad, cold climate is good, or anything like that. It's that we are heavily adapted to the current climate we live in. Most people live near the coasts. We have a lot of investment near coastlines. As sea level rises, it threatens all of that investment. If climate change was happening over 10,000 years, we wouldn't be talking about it because it would be slow enough that we could adapt easily without much cost. The problem is all about rate. It's all about how fast it's happening and what kind of displacement, both for humans and for natural ecosystems who are going to get caught slammed essentially by the speed of the change. And the question is, how will they adapt? Will they be able to adapt? Of course, made difficult by all of the roads and construction and agricultural fields and everything else that have divided up habitats. What climate change really is about is the cumulative global emissions of carbon dioxide. So we literally are all in the same boat. So we're not going to solve this problem until the world solves this problem. There's a lot of emphasis in businesses about being carbon neutral, or individuals worrying about their own carbon footprint. And that's very well-intentioned, but it's fundamentally flawed. But the other thing that humans are really bad at is dealing with long timescales. And every aspect of climate change has long timescales. And I'll talk about all of these: the climate system, the carbon cycle, and perhaps the least understood part of this is that energy systems themselves have really long timescales. I think the important thing to see is this is like the spatial footprint of global warming. And what you see here are a couple of really obvious things. First of all, you see that the Arctic's warmed a lot faster than the rest of the world. In general, the continents are warming a lot faster than the oceans. Warming over land has been about twice as fast in the last 50 years as it has been over the oceans. The ocean is absorbing heat, and the good news is that it's actually causing slower warming than would otherwise happen. If the Earth was completely covered with land, the response would be happening over a timescale of about 10 years. Because of the ocean, it's actually a timescale of more like 1,000 years. That's the good news. The bad news is that we're essentially committed to warming now. Even if we stopped emissions tomorrow, we would still keep warming the Earth for centuries, even a millennium, because the ocean is going to keep warming, trying to reach this new equilibrium state. Climate change challenges us in a totally different dimension. It challenges us to think on century timescale, and that's really hard. The carbon cycle makes this even worse. So just to quickly give you a sense of what's happening in terms of the chemistry, as we burn fossil fuel, about 60% of it, a little less, remains in the atmosphere. 40% is taken up by the ocean and the terrestrial biosphere. So the part that stays in the atmosphere is called the airborne fraction. And more than half of that airborne fraction will still be in the atmosphere 1,000 years from now. And about a third of it will still be there 20,000 years from now. So this is a graph showing global energy use from 1800. You can see the extraordinary rise in coal, and then oil and natural gas, hydro, those are the big hydroelectric dams, and nuclear. In this graph, hydro includes solar and wind because they'd be so tiny you wouldn't even see them. Starting around 2000, you can just begin to make out wind, and now solar is sort of coming on strong. This is a graph from DOE showing renewable additions over the last decade or so. And you can see there's some good news here. Recently, more than half of annual utility scale capacity additions, that is new electricity generating capacity, is wind and solar. For even half of our electricity to come from renewables because wind and solar, because the wind doesn't blow all the time and the sun doesn't shine all the time. There's this thing called nighttime. We're talking about adding something like 2,000 or 3,000 minimum gigawatts of wind and solar. And that would be only for half of our electricity in a decarbonized economy where electricity demand is probably 2 or 3 times higher because we've electrified transportation and electrified home heating and electrified industry as much as we can. So given all of that, we're building 20 gigawatts a year, but that means we're more than 100 years away from even getting to 50%. That the timescale of decarbonization is just longer than what many policymakers and climate change advocates imagine. And by the way, the hard part of decarbonization is the stuff that isn't just wind and solar. It's new technologies for energy storage, for advanced biofuels or synthetic fuels for jets and ships and trucks. Are we going to use hydrogen? Are we going to use other things? It's new infrastructure that again represents several hundred years of construction at current rates. And it seems unlikely to occur in just a few decades. That our concern about climate change is going to drive technological innovation, but we have to think about getting to a place where there are alternatives that are better. The good news is that we're on our way. So for example, electric vehicles. I think electric vehicles are very close to becoming a better choice. They're still a little bit more expensive than an internal combustion engine, but they're getting a lot closer. Similarly, global demand for wind and solar will happen when they're better choices, which they seem to be right now. In the US, we're building 75% wind and solar last year. Decarbonizing the US as quickly as possible, or Europe, is not the goal. I think one of the other dangers of the discussion of climate policy today is everybody's focused on national decarbonization. What matters is decarbonizing the world. It is a collective action problem. The whole point of leadership is to make this pathway of decarbonization look like it's an essential pathway for every country to follow.